Assume a poll of 20 BAF students is taken in an economic or research study. The purpose is to determine X, the number who prefer working in the banking industry. Suppose that 60% of all the BAF students prefer working in the banking industry. Find the mean and standard deviation of X. So as I said, the binomial experiment, you're going to have two outcomes. Okay, so here, this experiment, the two outcomes is either the student prefers working in the banking industry or the student doesn't prefer working in the banking industry. Okay, we've got two outcomes here. All right, we have 20 students who are testing. Okay, and either they can say they prefer working in the banking industry, or they can say no, we don't prefer working in the banking industry. All right, so here we want to calculate the mean and the standard deviation. Okay, X, this X here just represents the number of students. Okay, it's a representation of the number of students. Okay, so first we have to find the mean and the standard deviation, and then I'll interpret what they mean. Okay, so these formulae you'll be given in the exam. Okay, for a binomial distribution, to get the mean, have you seen EX here? This EX, it's the mean or the expected number, equals N times P. N represents the number of students. P represents the probability. In this question here, it told us the probability. Where is the question here? Yes, it told us the probability. This one, that suppose that 60% of all the BAF students prefer working in the banking industry. So this is our probability here. So you're going to say P is 60%, 0.6. Okay, P just represents the probability. Okay. N just represents the number of students. In this case, the number of students in this test are 20. Okay, so to get the mean, we use that formula. E x equals N times P. What is our N? 20. What is our P? 0.6. 20 times 0.6, what do we get? Twelve. So this is our mean. What it's telling us is that if you conduct this experiment multiple times, on average, 12 students are going to prefer working in the banking industry. Okay? On average, when you conduct this experiment multiple times, you get 12 students who prefer working in the banking industry. Any questions before we move further? Now we have to get the standard deviation. Okay? Remember, the standard deviation just shows how far apart from the mean a point is, and we're going to interpret it here in this question. So for the standard deviation, again, as I said, here's the formula. This is for the variance, but the standard deviation is the square root of the variance, okay? So that's how we're going to get the standard deviation, okay? So here, on our question, Standard deviation, we will present it as sigma. Oh, let me find space for it. Sigma, which is standard deviation, square root of n p and 1 minus p. So this p, as I said, it represents the probability that a student prepares working in the banking industry. This 1 minus p represents the probability that a student doesn't prefer working in the banking industry. Okay, so this 1 minus p, sometimes it can be represented as q. Okay, n p q. Okay, this 1 minus p can also be represented as q. So n is the number of students who are conducting this test on. P is the probability that the student prefers working in the banking industry, which is 60%. Q is the probability that the student doesn't prefer working in the banking industry. So if the probability is that students prefer working in the banking industry is 60%, what is the probability that students don't prefer working in the banking industry? If total percentages end up to 100%, what is the probability that students don't prefer working in the banking industry? 0.4 or 40%. Okay. Just remember with probabilities, when it's in percentage form, just remember percentages end on 100. So you usually, in most of these questions, you usually be given your P. Q, it's for you to determine for yourself. Okay. So 100 minus 60%, we get 40%. Okay. 40%. And this 40%, we present it as 0.4. Okay. So we substitute our values. N is 20, P is 0.6, Q is 0.4. So let's multiply 12 times 0.6 times 0.4. What do we get? Oops. 20 times 0.6 times 0.4, 4.8. What is the square root of 4.8? 2.19. Okay. 2.1 or 2.2. Okay. So let me interpret this standard deviation. Twelve 12 plus 2.2, that is 14.2. 12 minus 2.2, 10.2. But since we're dealing with students here, number of people, so Decimals really don't matter, so we just put 10 and 14. Okay, so what the standard deviation is telling us, okay, since we say that on average, when we conduct this test, we expect 12 students to like working in the banking industry. Okay. But it's not all the time that you're going to just get 12 every time you conduct this test multiple times. Sometimes you might get 11 students, you might get 10 students, you might get 13 students, you might get 14 students. Okay. So this is the range basically where we're expecting to find our average every time we conduct this test. Okay. Every time we conduct this test, if we conduct it multiple times, you might find 12 students. The next time you try to conduct this test, you might find it's now 10 students. Maybe the next time you conduct the same test, you might find it's 14. Okay, so the standard deviation is just giving us a range basically of where we expect to find our average if we conduct this test multiple times. Any questions? Yes. Oh, yes, yes. Whatever percentages you are given, convert them all to decimals. Okay. Yes. So that's what these two things are telling us, the mean and the standard deviation. Okay, it's giving us a guide on what to expect if we conduct this test multiple times. Okay. On average, you expect to get 12 students liking to work on the banking industry. Okay. But remember, certainty is not, we can't be 100% certain. So other times you find it won't be 12, maybe 10, 14, 13. Okay. Even maybe even further. Okay. So the standard deviation is just giving you an idea of what to expect if you try to conduct this test. And next time. Okay. Now, these were the easy parts. Okay, because the mean and the standard deviation, very easy. In the exam, you just look here, oh, here are my examples. Now, this is the formula we're going to use for calculating probabilities. Okay, because here the mean and the standard deviation, those are not probabilities. Okay, here now we're going to start calculating probabilities. Okay, so the next part reads the question: find the probability that at least a quarter of BAF students favor working in the banking industry. Okay, so first things first, we need to find out what is a quarter of 20. Five, right? So we have to find the probability that at least a quarter, meaning at least five students prefer working in the banking industry. Okay, so Hello, hello, hello. Okay, was kicked out. My band was finished. Yes, we're trying. We're on part B here where it says find the probability that at least a quarter of students favor working in the banking industry. Okay, so a quarter of 20 students is five students. Okay, so I'll find the probability that at least five students, okay, prefer working in the banking industry. So, colleagues, when we say at least five students, it means we're also interested in the probability that six students like working in the banking industry, seven students, eight students, nine students. Because when they say at least, it means five is the minimum, right? Five is the minimum. Okay. So it means since five is the minimum, so we have to also find the probability that six students like working, seven students, eight, nine, 10, 11, up to 20 students. Okay. But the thing is, that would be a lot of calculations. Okay. Because to get each of these probabilities, you have to be using this formula. Okay. Where is this formula here? Okay. This same formula here. So what you can do is this. Instead of calculating all the probabilities from 5 to 20, okay, you can use this rule in probability, okay? Mm-hmm. Yes. Yes, sir. Yes, it's being recorded, sir. Sure. Yeah, yeah. Colleagues, can you clearly get me? Okay. So pay attention to this part. We want to find the probability that at least five students prefer working at the banking industry. Okay. So when we say at least five students, okay, it means you want the probability for five students, six students, seven students, eight students, until you reach 20 students. Okay. But if you calculate that way, it's going to take you a very long time. Okay. It will take you a very long time to calculate all those probabilities from 5 up to 20. Okay. So you can use the complement rule. Okay. This probability for at least five students is catering from 5 to 20 students. This probability which I've put here is catering from 1 to 4 students. Okay. So what we can do using the complement rule, since we want to find the probability that at least five students are working in the banking industry, is we take this other probability here, probability that less than five students working in the banking industry. We find that probability that at less than five students prefer working in the banking industry. Once we find those probabilities, when we subtract them from 1 It will give us the probability, this probability we are looking for. Let me repeat myself again. We want the probability that at least 5 students are working in the banking industry. So we have to calculate the probabilities from 5 to 20 students. Now, that is going to be a long process. So we can use the complement rule for probabilities. Okay. We can use the shorter method. We find the probability that less than 5 students prefer working in the banking industry. Once we find those probabilities, we subtract them from 1. And when we subtract them from 1, it will give us the probability that at least 5 students prefer working in the banking industry. Any questions? Okay. So here, with the shortcut method, one find the probability that less than 5 students prefer working in the banking industry. So this will include the probability that 0 students prefer working in the banking industry, plus the probability that 1 student prefers working in the banking industry, plus the probability that 2 students prefer working in the banking industry, plus the probability that 3 students prefer working in the banking industry, until we reach 4 students. Probability that 4 students prefer working in the banking industry. Once we find 1, 2, 3, 4, 5, these 5 probabilities, and add them up, and we subtract them from 1, it will give us the probability that at least 5 students prefer working in the banking industry. Now, if you're not comfortable with this method, okay, if you're not comfortable with this method, this is the long cut. Since you want the probability that at least 5 students prefer working in the banking industry, so you start probability that 5, or, or 4. Yes. Yes. So I'm saying if we don't use this shortcut method, the long cut, okay, you have to find the probabilities from 5 up to 20. Okay. Now that would be a lot of time because, as you see, the formula is kind of big for this. So it will take a lot of time for you to calculate probabilities from 5 up to 20. So you're better off calculating probabilities from 1 to 4. Then when you get the probabilities from 1 to 4, and you subtract them from this one here, you get the probabilities from 5 to 20. Is that okay, colleagues? Any questions? So this is the formula for the binomial distribution. Maybe let me write it in markers so that we can see it. P x equals x equals, I'll explain what everything means. Let me just write the formula down. N factorial over n minus x factorial x factorial multiplied by p to the power x multiplied by q to the power x. Okay, this is a formula we're going to use to calculate these individual probabilities. Okay, so we're going to start with x, with the probability that 0 students prefer working in the banking industry. So x, remember, it represents number of students. Who we are investigating. N is the total number of students, so n will always remain 20. Okay, x just represents the number that you're investigating or interested in. All right, p is still that probability, that's 0.6, and q is that probability 0.4. So we start with the probability that 0 students prefer working in the banking industry. X equals 0. So n, remember, is always going to be 20. So say 20 factorial divided again by 20 minus 0 factorial. Remember, where there's x, you're just replacing 0. 0 factorial multiplied by p 0.6 to the power x, which is 0, multiplied by q, which is 0.4. You can already see people saying, this question, I'm not doing it in the exam. This question, I'm leaving it. Oh, it's q to the power n minus x, sorry. Okay, in the question, it told us that here, 60% of all the above students prefer working in the banking industry. Okay, so that's the, yes, in this question, you're testing 20 students. Okay, it's a binomial experiment. And there are only two outcomes in this experiment. It's either you prefer working in the banking industry or you don't. So the probability that a student prefers working in the banking industry is 60%. So that's where the 0.6 came from. Then this 0.4, this 40%, represents the probability that a student doesn't prefer working in the banking industry. Yes. So now with this question, we want to find the probability that at least 5 students prefer working in the banking industry. Okay. We're trying to find that probability. Uh-huh. Yes. Was that a question? I'm telling you, I'm seeing people. Okay. I see people not doing this question because look at the amount of work that we have to do. Okay. We have to calculate all these probabilities from 0 to 4. Then we add them up and subtract from 1. Yes, what's the next question? Because remember, here, according to this formula, one find the probability that less than 5 students prefer working in the banking industry. So that includes from 0 students up to 4 students. So that's where the 0 is coming from, okay? Since we here want to get the probability that less than 5 students prefer working in the banking industry. So we want to get, yes. Okay, so the fun part begins. Okay, remember factorials? Remember how we did them? Yes. So so here 20 factorial divided by 20 factorial is 0 factorial. Okay. What answer do we get? Those who don't remember factorials, 20 factorial is the same as saying 20 times 19 times 18 times 17 until you reach 1. Okay, you're counting the number down until it reaches 1. Okay. Whenever you see this factorial sign, you'll be multiplying the number with the numbers below it until you reach 1. Okay. But in this case here, you don't really need to do that because you can just cancel these two out. Okay. Because there are 220 factorials here. Okay. So if you cancel them out, you get 1. 0 factorial is also 1. Okay. So this tabulation here, we are going to get 1. Are we okay with that, colleagues? This 20 factorial divided by 20 factorial, 0 factorial. You just cancel out the 20 factorials. They will equal to 1. 0 factorial is equal to 1. Are we okay with that, colleagues? um, the reason why I'm not sure, but 0 factorial equals 1. Just if you want to verify this, just check. Okay, 0 factorial equals 1. Okay, the reasoning behind it, I'll investigate for you. Okay, madam, I'll investigate. Yes, yes, but that's a good question. Okay, that's a good question. Okay, so this tabulation here, we get 1. 0.6 to the power 0. Remember, anything to the power 0 is 1, right? 1. So we have 1 times 1. Then here, 20 minus 0, that is 20. So we're saying 0.4 to the power 20. In your calculators, can you put 0.4 to the power 20? Can we put 0.4 to the power 20? No, I found it. I found it. As we're calculating, remember, colleagues, here all that we're trying to do is one find the probability that less than 5 students prefer working in the banking industry. Once we find that probability and we use the complement rule, Okay, we can find the probability that at least five students prefer working in the banking industry. Okay, think of this as those are calculating there, but to those who are not calculating and are still confused, okay, think of this expression here as a number line. Okay, think of this as a number line. Okay, this p less than 5 is from 0 to 4 students. Okay, it's from 0 to 4 students. Then p less than or actually it's actually it should be greater than or equal to, because when we say at least it means 5 is the minimum, so it has to be like this, greater or equal to. Yes, this is from 5 to 20. Remember, we have got 20 students. Okay, so think of this as a number line. Okay, so once we get this part of the number line and subtract it from 1 using the complementary rule, we'll be able to get this probability. Yes, what is 0.4 to the power 20? Yes, Mr. Trumbo, what is 0.4 to the power 20? Haven't you got an e to the power negative 8? No, you haven't made a mistake. You get 1.099 e to the power negative 8. That negative 8 means you have got 8 zeros before the 1. 0.1, this is 2, 3, 4, 5, 6, 7, 8. Then you put that 1, 1, not 10, 109. Yes, so here you put 109. Okay. Colleagues, when you see that e the power negative whatever, this is the power negative 8, that means the number of zeros before your number is going to be 8. Okay, so 1 times, yes, 1 times 1 times 1 times this number, you get 0.2345678. So this is the probability that 0 students prefer working in the banking industry. Okay, very low probability. Yes, any questions? Is this the probability of you understanding these topics? Is this the probability of you understanding this topic? Yes. Okay. Any questions? Sorry, I was just, it's good to laugh at times. Yeah. Any questions, colleagues? Now the process continues, colleagues. Okay, because we have to find all of these probabilities. Next, we now go to the probability that one student prefers working in the banking industry. So the same process again. Okay, and you can imagine this is the exam. Okay, and okay, this question, the exam, don't attempt if you haven't yet understood, because it will take you a lot of time. Okay, the probability that one student prefers working in the banking industry. So this same formula, n factorial 20 factorial over n 20 minus x in this case is 1, so you have 20 minus 1 factorial, then here x factorial again, 1 factorial, multiplied by p. Remember, p is always going to be 0 0.6, p to the power x, so it is going to be 0 0.6 to the power 1, multiplied by q, which is 0 0.4. Hello, madam, are you saying something? Yeah, low. Yeah, low. Could you just speak up? Very clear now. It's separate. It's separate here. Think of this as its own fraction, so not above or below the line. Okay, not above. Yes, on the, although on the same line with the line. What? Have you seen? Just like this here. This nx here, it becomes n factorial over n minus x factorial. Okay. So you must remember, yes, you must remember this, colleagues, because in the exam you have this, they'll give you this formula, but this part you must remember that it's this. Okay? Yes. So, madam, are you going to attempt this question in the exam? Yeah, it can be the last one. I can't blame anyone if you. Okay, so 20 here. 20 minus 1, it's 19 factorial. So we have 20 factorial over 19 factorial 1 factorial. Okay. So to make life easy, colleagues, because in the exam you don't write 20 times 19 times 18 times 17 until you reach 1. That would take a lot of time writing that. Okay. What you can do is you say 20 times, then you end on 19 factorial because 19 is at the bottom here. Okay. You end on 19 factorial. Okay. 20 times 19. So that these 19s can cancel each other. Okay, colleagues? You don't need to write everything down. So if you see a 19 factorial down here, just write 20, then end on 19 factorial so that these 19s cancel each other out. 1 factorial is 1. Okay. 1 divided by 20, you get 20. Is that okay, colleagues? You don't need to write from 20 up to 1. No. You just look at your denominator and end where the denominator ends. Okay, colleagues? End where the denominator ends. Okay. So 20 factorial divided by 19 factorial, 1 factorial, you get 20. Okay, you get 20. All right, so where will I put it? 20 here. Multiplied by 0.6 to the power 1, 0.6. Multiplied by 0.4 to the power 19, because 20 minus 1, that is 19. So 0.4 to the power 19, what do we get? Okay, another 8 zeros. Ish. And my hand is hurting now. Drawing all these zeros. 1, 2, 3, 4, 5, 6, 7, 8. Then 274. So let's multiply 20 times 0.6 times this number. What do we get? Okay. 2, 3, 4, 5, 6, 7. 2, 238. Okay. Any questions? Okay, we get the probability now that two students prefer working in the banking industry. So say P equals 2. Okay, we refer to the formula again. N factorial always going to be 20. Okay, 20 factorial divided by n, which is 20, minus x. X is, in this case is 2. So 20 minus 2 factorial. Then we have a 2 factorial here. Okay, this last x factorial. Multiplied by p, which is 0.6 to the power 2, multiplied by 0.4 to the power n minus x. So n minus x, that is 20 minus 2. So we solve again. Okay, so here we have 20 factorial. We solve this on the side. 20 minus 2, that is 18 factorial. 2 factorial. Okay, so as I said, since we've seen in our denominator, it's 18 factorial, so you just write 20 times 19 times, then you end on 18 factorial here. So that the 18 factorials cancel each other out. Okay. Then below this 2 factorial, this is 2 times 1. Okay. So what is 20 times 19? Then divided by 2, what do we get? Mhm. 190. Okay. 0.6 to the power 2. Where is it just Mr. Twambo answering? Madam Yvonne, Madam Beth, Madam Helen, Mr. Cason. Yes, 0.6 to the power. Yes, 0.6 to the power 2. Yeah. Okay, drive safely, Sam. Okay, just because if you see what we are solving, you see what we are solving, Mm, you park first and say, what is this now? You park. Okay. Yes, 0.6 to the power 2. Okay. 0.4 to the power 18. What's the numbers? 1, 2, 3, 4, 5, 6, 7. Uh-huh. Then what's the number? Okay. Okay, at least there's participation. At least I'm happy. Okay. Because when everyone is quiet, I start wondering. Okay, so 190 times 0.36 times this number here. 5 zeros. 3, 4, 5. Like this. Okay. Mm. Mm. Oh, okay. Okay. Mr. Twambo, it's 6 zeros overall, right? Okay. Okay. The madam was saying it's 5 zeros after the point. So yeah, both correct. Then what's the number here? Okay. Okay. Probability that 3 students prefer working in the banking industry. Okay. So again, 20 factorial, which is n, divided by 20n minus 3, which is x, factorial, 3 factorial, multiplied by 0.6 to the power 3 multiplied by 0.4 to the power 20 minus 3, that is 17. Okay, so 20 minus 3, that is 17 factorial. So we have 20 factorial over 17 factorial, 3 factorial. So since we say 17 is at the bottom, so we'll end on 17. So we say 20 times 19 times 18 times, then you end here, 17 factorial. Okay, over, so this 17 factorial, we cancel them. This one goes, this one comes. 3 factorial is just 3 times 2 times 1. Okay. Okay. So 20 times 19 times 18, what do we get? Then divide that by 3 times 2 times 1. Zero point 0.6 to the power 3 multiplied by 0.4 to the power 17. Three, 4, 5, 6, 7. Okay, 171. Okay, so when we multiply 4,560 times 0.216 times that number, what do we get? Okay. Mm-hmm. Yes. Have you divided it by 6? Mr. Twam. Yes, you're correct, madam. You're correct. Mr. Twam, where did this 4,000 come from? As you like asking, then when we multiply with this, I'm getting 5 zeros, 42, 0 point. So one, 2, 3, 4, another 0. Is everyone getting this when you multiply 4 to 1? Okay, at least now you can imagine if you went with the original way for where you just say, okay, probability at least 5. Then you start calculating these probabilities from 5 to 20. Imagine what time you're going to be done. Okay, so now probability that 4 students prefer working in the banking industry. 20 factorial divided by 20 minus 4 factorial, 4 factorial multiplied by 0.6 to the power 4 multiplied by 0.4 to the power 20 minus 4. So it's 20 factorial divided by 16 factorial, 4 factorial. So we can just say 20, since 16 is at the bottom, so 20 times 19 times 18 times 17 times then you end 16 factorial. So that the 16 factorials go. Then 4 factorial is 4 times 3 times 2 times 1. Okay. So let's do our calculations. So someone else can calculate zero point 0.6 to the power 4, someone else can calculate zero point 0.4 to the power 16, and someone else can calculate this one here. Mr. Trumbo, which one would you like to calculate? Madam Sylvia and Madam, who else is here? You can find there are only 2 now remaining. And there are 5 remaining. Okay. Okay, Mr. Trumbo, can you handle this zero point 0.6 to the power 4? Okay. Madam Helen, can you handle zero point 0.4 to the power 16? And please give correct figures, okay? So that when you are watching this video, okay, so zero point 0.4 to the power 16 is 0. How many zeros are these? 6, 1, 2, 3, 4, 5, 6, 4, 2, 9. Mr. Tom, have you got zero point 0.6 to the power 4? Okay. Just praying this whiteboard hasn't erased those working scores. Okay. Yes. What values did we get? 0. 0.6 to the power 4. Then 20 factorial divided by 16 factorial, 14 factorial. And you get? Okay. We multiply 4,845 times 0.129 multiplied by 0 point this number here. In real life, colleague. Why do you want to know? So that you don't do it. Yeah. This one, I think it's also 10. It's a long process. That's what I'm saying. That yes, we've catered all the topics, the whole module. Yeah. So this question, if I recall, it's 10 marks. But you've seen the amount of work that you have to do. You have to spend time. Unless in the exam, okay, you finished all the other questions and then you just say, okay, we just got one more question. These are the ones you do at the last. Do not attempt to start with this one because you'll find 3 hours have passed and you're still on this party. Okay, and the exam takes, is it 60% of your grade? 60% of your grade. So if you just get 10 marks in the exam, your grade is going to go down. Even though your assignments and everything have kept you well, but if you get a low mark, the exam is what usually pulls because it carries a high weightage. Okay. Have we calculated this value here? Because my hand right now, it's my finger which I'm drawing with this, it's hard. Writing all of this here. Mm, mhm. Okay. We need to verify this because who else? Who else? Who else? Who else? So, Mr. Twambo, what's happening tonight first? What calculator are you using first? Because this is now strike two. Eh, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, maybe let me confirm. Okay, me I'm getting, but colleagues, actually, Mr. Twambo is correct. Me I'm also getting four zeros. 262 or 263. So, Mr. Twambo, actually, you're correct here. Your calculator is okay. So, Madam Beth and Madam Sylvia, how are you getting seven zeros? One, two, three, four, five, six, seven. This is now serious. Sure. Oh, network missed up. Hmm? Is it me? Colleagues, can you get. Mm, where, are you, where are you rounding off? Okay. Mm, okay, for now, let's just finish up the question. Okay. Then we'll retry our calculators. But I tried this also. I got 0.00263. Okay. Maybe it's the number of zeros that you put here. All right. Yes. So we need to add these probabilities. Okay. Because as you remember from the formula here, probability that less than five students prefer working in the banking industry. So we need to add all these probabilities. Okay. And to give us the total probability of less than five students prefer working in the banking industry. So it's why is it doing this? Can you get me? Okay. Because usually when the board, when it says refreshed, that's when I know that I'm kicked out. I don't know now. Maybe the network is getting confused by these calculations and saying, "Sir, just go and sleep. This is too much." Huh. Huh. Those are not going to attempt this question. Those, they won't attempt this one. Anyway, there's another question on binomial distribution. So At least when we reach it, at least you have an idea at least. Okay. Mm. Yes. 1, 2, 3, 4, 5, 6, 7, 1, 0, 9. So we're adding the probabilities. This is how many? 1, 2, 3, 4, 5, 6, 7 again. 1, 2, 3, 4, 5, 6, 7. Six, seven, eight. Okay, this one's 8. So 1, 2, 3, 4, 5, 6, 7, 8. Okay. And here it's 3. Let me put them properly so that I never get exhausted like this. But binomial distribution, this topic, it's a handful. 1, 2, 3, 4, 5, 6, 7. So this 3 comes under this 0, then 2, 8. Here 1, 2, 3, 4, 5, 6, 6 zeros. 6 zeros, 4, 6, 9, 9. So 1, 2, 3, 4, 5, 6. Then we have a 4, 6, 9, 9. Then here we have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 4, 2, 1, 4, 2, 1. Then finally we have 4 zeros, 2, 6, 3. 1, 2, 3, 4, 2, 6, 3. Okay, colleagues, can we add these up? Let me zoom in. So the first one has got 8 zeros. Okay, 0 point. So 1, 2, 3, 4, 5, 6, 7, 8. Then a 1, 0, 9. The second one, 1, 2, 3, 4, 5, 6, 7 zeros. 3 to 8. And the third one, 1, 2, 3, 4, 5, 6 zeros. 4, 6, 9. So the number of zeros are just reducing. Okay. Tell me what we get as our final answer. So those who want to get a master's in mathematics, this is what you'll be doing. Hello, are we there? Okay. Now we've reached down to four. Four. And if this question went further, you would find now it's. But I believe, yeah, from here, no one's going out. No one's logging out. I trust me. I wouldn't. I wouldn't even advise doing this question. I wouldn't. Okay, yeah, it's manageable. It's The only thing I just hate about these questions is these numbers with a lot of zeros. That's where they're too much. And if you add now pressure in the exam there, you forget 1 0. Oh, but I think we can add this one easily. 0.0002 6 plus 4 10. Right, just as I calculate. If this question was just structured, maybe find the probability, two students, one student, it would have made life easy because we would have already found those with the formula. Now, when you say at, so colleagues also remember, whenever you hear the word at least, it is this sign here. Okay? When they say at most, it's this sign here. Mm-hmm. So, yes. Mm-hmm. 3098. What about this number which had how many? Eight zeros here. Then the numbers have to continue. 8427, like this, huh? Okay. Okay. Colleagues confirm. Yeah, colleagues confirm. It's the same as 0.03%. Okay, madam. So subtract this number from 1. Okay, do 1 minus this number. Okay. Because remember, according to the formula here, it is 1 minus the probability that less than 5 students prefer working. So 1 minus this number. Here. Uh-huh. Mhm. 310 31. Mm-hmm. Okay. Subtract 1 from it, you get you but you get a 0.9999 something. So that's a probability that at least 5 students are working in the banking industry. 99.67%. So from this experiment, you can tell that majority of the students prefer working in the banking industry. No, majority of students prefer working in the banking industry.